Hello everyone, welcome at the first breakout session. We're going to talk about measuring and understanding behavior of shared mobility users. We're all working on hubs, new mobility modes, new ways of using mobility, but of course the modal shift is not enough. We also need a mental shift because people have to change their habits, and that's where our experts come in. I'm happy to introduce Francao Liao, who is a postdoc researcher at TU Delft. She's gonna explain the postdoc she's working on. And Kuldeep Kafta, who is a research associate at the Newcastle University, who will also talk about his research. At the end, there's a lot of time for questions, so please save your questions and you'll get the time to ask them. Thank you.
Thank you, Yasmin. Hello, everyone. My name is Francao Liao. I'm working as a postdoc researcher in the Transport and Planning Department at TU Delft. As an academic partner in eHubs project, TU Delft has been mostly focusing on modeling people's behavior in terms of eHubs. So today in my presentation, I will briefly introduce the methods we use to measure and model people's behavior and also some preliminary results. Since you're at the conference today, so you probably already have a rough idea of what eHubs are. So eHubs are on-street locations which integrates multiple types of shared electric modes, including e-bikes, e-cargo bikes, and electric cars or e-scooters. And eHubs can vary in size and type of location and also the type of transport modes they offer. So when we say we want to understand people's behavior of using shared mobility or hubs, mostly we want to answer two main questions. The first one is, when eHubs were not available, we want to know that when they become available in the future, will people use it? And in order to answer this one, we would have to measure and understand people's expected future preferences for this new transport service. And the second main question in our task is, after eHubs become available as pilots or in a bigger scale, did people use it? To answer this question, then we will have to measure and understand people's actual behavior and also any change in behavior when eHubs are implemented. In my presentation today, I will only be looking at the first question. If you're also interested in the second question, please stay in the same room for the second breakout session for Newcastle's presentation, because they will cover that. So to answer this main question, what are the specific research questions we would like to answer? Here I have three. The first one is, what factors would affect people's choice of using shared mobility or their choice of transport mode in general? And the second question is, who are more inclined to use shared mobility? And this would give us an idea of the typical user profile for shared mobility using. And the third question is, do users of different modes differ in terms of their shared mobility preferences? The reason why we're interested in this question is because, as we also heard in the opening session, that the point of eHubs is to give people who are currently using private cars an alternative to use a more sustainable mode. But because eHubs, of course, is available for everyone, so it can also be attractive for people who are currently using public transport or walking or cycling. And in terms of sustainability, that is probably not an ideal result we want to see. So we would like to understand this to have a better idea of the real net impact of eHubs. So this is also very important. Here I would like to give you an idea of how we can measure people's future preferences for something which does not exist yet. Because when we conducted this study, eHubs was nothing more than just a blueprint picture on here, you can see. So what we did was to conduct a stated choice experiment. What is a stated choice experiment? It is basically a number of choice tasks. And on the screen you can see this is an example of a choice task. In a choice task, we would provide several alternatives for each respondent. So in this example, you can see there are three, namely the person's current transport mode, which is public transport, and also two shared electric modes from e-hubs, namely shared electric vehicle and shared e-bike. And each alternative is described and characterized by a list of attributes. For example, their access and egress time, travel time, and travel cost. So given all this information, a respondent is supposed to choose the most preferred one. And each respondent will receive a number of choice tasks, and the tasks will differ in terms of the attribute values. And by seeing how their answers switch when these attribute values change, and we can use statistical modeling to derive to what extent these attributes would affect their final choice. So this is our study approach. And I would also like to discuss a bit more about the experiment design and assumptions, so you would have a better idea on how our results would be applicable and in contrast to reality, because of course in our study the context can be slightly different from the e-hubs we have right now. For example, there are some assumptions in our study which are different from the current e-hubs implementation. The first one is that in our experiment, we assume that e-hubs is a one-way station-based system. So you do not have to return the shared vehicle to your original pickup point, which is probably not the case for many e-hubs which are implemented right now. And the second one is we assume that there is no parking search time for shared mobility modes. And also that shared vehicles are always assumed to be available. So we also do not consider the influence of availability in our study. In order to cover a wide range of trip context, we included multiple trip purposes, including commute, non-commute, and which includes shopping and leisure trips. And we also use a customized design for every respondent, because you can see that one of the alternatives is their current mode. So this is closely tailor-made for every respondent, depending on their current mode. We did the data collection in 2021 May among adults with driver's license living in Amsterdam. Of course, we also collected data from Manchester, but we will only present the results in Amsterdam. With the help of a panel company, in the end, we reached a sample size of 1,003, of which 95% are car owners. And we used statistical choice models and scenario simulation to derive our results. Of course, I will not bore you with the boring details of these methods. I will directly show you some findings. So if you can still recall the three research questions we want to answer, the first one is, what factors are influential for people's mode choice? So we can see these are the first answers for this question. First, we can see that trip purpose. One of the things we wanted to know is whether, because for shopping trips, people are loaded with goods or cargo, so maybe they would be less inclined to use shared mobility because it's less convenient. But our modeling showed that this is not an issue for people, so shared e-cargo bike is also a viable option for shopping trips. And other factors which are influential for people's choice, of course, for the shared mode attributes, their travel cost and travel time are, most of them are significant. So people will be affected by these attributes, which are, of course, intuitive. Apart from the shared mode attributes, we can see that the current mode attributes also have a significant impact. For example, the parking cost and parking search time for private car owners. There may be some policy options there. For example, if you would increase the parking cost and parking difficulty for car and private car owners, this can be helpful in switching them towards shared mobility using. And the second batch of findings is regarding the typical user profile. What types of people or what socio-demographic groups are more inclined to use shared mobility? So we can see that gender does not have a significant impact on the use of shared mobility, while young people below 35 years of age are significantly more inclined to use both types of shared mode. As for people who are above 65 years old, they do not, there is no difference for them compared to middle-aged people in terms of shared EV, but for shared e-bike, they do prefer this less, which is possibly due to their lower, maybe due to their physical capability of using it. People who are higher educated are more inclined to use shared e-bike, but not shared EV. And people, families with children are more inclined, are actually more inclined to use shared mobility, which is also an encouraging result, showing that the shared mobility does not necessarily mean extra inconvenience for them. But of course, one thing to come to mind is that we did not specifically mention that the trip is for a trip with children. So we're not sure whether this did play an impact there. But at least there was no negative impact to be seen. And this is the third batch of findings to look at whether the current transport mode have any influence on people's preference for shared mobility. And we can see that indeed public transport users, as we fear that they are indeed more likely to switch towards shared modes compared to private car owners. But an encouraging result, we can also see that active mode users, which are people who are currently cycling and walking, they still have a very strong inertia for their current modes, which means that the vast majority of them will still stick to their current mode and not be turned away by e-hubs. But when the distance increases, for example, if the trip is longer than 2 kilometers for a person who's walking, or a trip is longer than 5 kilometers when a person is cycling, then suddenly there would be an increased percentage of people switching towards e-hubs. As for the relative preference between the two shared modes, shared e-bikes and shared EV, we found that current bike users prefer shared EV more than shared e-bikes, while it is the opposite for people who are using public transport and walking. A possible explanation for that is because maybe current cyclists are already used to cycling and they do not perceive a huge added value from e-bikes. So they would only switch towards EV when they feel that bike is really not a viable option anymore, or it's much less convenient. And one more thing to note is that shared e-bike use increases with distance. So showing that it is actually a viable option for slightly longer distances, which are traditionally considered to be too long or too inconvenient for active modes such as cycling or walking. So that is also a positive result in case. So that's my presentation for today. Thank you.
Hello everyone. I'm Kuldeep Kauta. I'm from the Newcastle University. I'm working as a postdoc research associate there. And I got involved in this project since last February. So the current presentation that I'll be showing is mostly the ongoing work, where I'm showing a comparison between Amsterdam and Manchester. So how these two cities differ in terms of their e-hubs adoption. So the broad things that I will be covering is like the differences and similarities between in the travel behavior in these two cities, and uh, a small research exercise I will be presenting here. It's about we are trying to see if we can transfer the model. So as Fenchao had shown that they have developed a model for Amsterdam. So we are trying to see if these models can be applied to Manchester, and how are the results there. So we are trying to check the spatial transferability as well. So this is what I'll be covering my today's presentation. Yeah, so the contents follow the first. I will be explaining the descriptive comparisons between the two cities. So this will cover the socioeconomic profiles between the Amsterdam and Manchester to give a broad idea about how they differ and how they are similar. And then the second part is about the spatial transferability of models, where we are trying to see if the choice models that are developed for Amsterdam can be applied to Manchester City. And we'll try to find the implications of this transferability. And of course, the last part is about the comparison between the models for Amsterdam and Manchester at a parameter level. So there are few differences between the two preferences of users in both the cities. So we are trying to cover that part in this third part of the presentation. So coming on to descriptive statistics. When we see the similarities between the two cities, they are quite similar when it comes to their gender composition, education level, and income levels. And surprisingly, both the cities are also same when it comes to their car ownership. So the data was collected in both the cities, and it was found that the car ownership is roughly the same in Amsterdam and Manchester. And when it comes to the differences, Amsterdam is like, on an average, the number of households with children are more in Manchester as compared to Amsterdam. So as Fenchao was mentioning, we also see the impact of, the results are not showing as such the impact of having children on the choice that they make. However, one of the studies that we did in Newcastle, where we are trying to identify different clusters of population. So there is clear distinction between a cluster of population with children and without children. Their travel behavior is quite different. So Amsterdam and Manchester also differ in their number of children in the households. They also differ in the occupation types. So in Manchester, more people are employed in full-time employment as compared to Amsterdam. And most important difference in their travel behavior is their current mode share. So Amsterdam is like very, Manchester is a car-dominated city. As you can see, 3/4 of the trips are being made by cars, whereas Amsterdam is having a very good share of bikes. So clearly the distinction can be made between their travel behavior patterns. And surprisingly, as I explained in my previous slide, the car ownership is roughly the same. Now, coming to the spatial transferability. So as Fenchao mentioned, that they did a choice experiment, stated choice experiment to identify what people, what they are choosing, what respondents are choosing. So they had 3 options: public transport. The first option is the status quo. So they will continue to drive whatever they are driving currently. The second option is about shifting to the shared electric vehicles in the e-hubs. And the third is going to the shared electric bikes. So also the data was collected on the socioeconomic profile of people, their education, gender, income, age. And then using the softwares, the models were developed. So this is getting a bit technical here, but the models have this format. So the utility of any mode depends on the variables. So all these socioeconomic variables. And each variable has a sensitivity in the model. So the beta value explains the sensitivity of that variable in the choice. And the constant part explains all those things that we have not captured from the respondents. So the utility of the model mode depends on, has this type of structure. So this is what Fenchow had developed for the Amsterdam. So this green part indicates the constant part. So all those things that we are not captured from the respondents, and the red part indicates the all these variables and their sensitivities. So two different models were tried in Amsterdam. First is the MNL model, and the another one is mixed logit. So the basic difference between these two models is that the MNL model is assuming a fixed value of estimates for the constant values. So the green portion in MNL is fixed for all the respondents, whereas for mixed logit model, this green portion varies for each and every respondent. So in a way, the mixed logit model is more flexible in accommodating the preferences of each individual. So now what we are trying to see is whether this developed model can be applied to Manchester or not. And this is the formal definition of spatial transferability. What it means is the application of a model, information, or theory about behavior developed in one context to describe the corresponding behavior in another context. So this is what spatial transferability means. Now, how it can be evaluated? So there are two different measures through which we can check this spatial transferability. First is called transferability index. Here we are, it shows the predictive accuracy of the transferred model. So in our case, Amsterdam model, relative to the locally estimated model. So we have also estimated a model separately for Manchester, and we are trying to see how close is this Amsterdam model if we apply it on the Manchester data. And the value of this measure ranges from 0 to 1. So let's say if it is 1, it means that the Amsterdam model, when applied to the Manchester data, is performing as good as estimating a separate model for Manchester. And the another measure for evaluating the transferability is called as root mean square error. So this is the, we are trying to see whether this Amsterdam model is reproducing the choices. So in absolute terms, if I apply the Amsterdam model on Manchester, whether it is correctly predicting the choices or not. So this is an error measure. So lower the value, better is that model. And three different approaches were tried here. So in first approach, which is called as naive approach, we just take the model as it is and apply directly on the Manchester data. And the second approach and the third approach, we adjust the model a bit to see if the transferability can be improved. And here are the results. As we can see, the transferability value is quite high for the mixed logit models. Just a minute. Yeah, so the orange line, somehow it's not coming in my presentation, but the orange line indicates the transferability values for the mixed logit model, and the blue line indicates the transferability for the MNL model. So it can be clearly seen that the MNL model is not at all fitting the Manchester data. But if we use the mixed logit model, it has a very good value of transferability index, which is 0.7. And if we compare it with the published studies, the 0.7 value is a very good value. So we can say at least 70% of accuracy is there when the Amsterdam model is applied to Manchester data. Talking about the RMSE values, again, the orange line is having the lower value. That means when the Amsterdam model is applied, they are correctly the mixed logit is predicting more accurately as compared to MNL model. And this is the concluding this thing that if the mixed logit model are applied with an updated scale, so you cannot just transfer the mixed logit model, but you also have to update the scale considering the local situation. So if you update the scale and then apply the mixed logit model, then you get a very good spatial transferability. So these are the table that is shown in the right bottom corner. It shows the observed value of each mode. So for example, people who are choosing the current mode is 79% in the observed data. But when we apply this Amsterdam model to the Manchester data, it is giving the value of 76.5, which is very close. So the shared electric modes, the share of the electric vehicles is somewhat higher as compared to the observed value. So whereas the shared electric bikes, the predicted share is somewhat lower as compared to the observed value. But the overall picture is that when this model is applied on the Amsterdam data, it is fairly correctly predicting the choices of respondents. The utility of this exercise is that now we have a idea that if the model is developed correctly, and if then we apply to other cities, then we don't have to re-estimate the models every time a new eHubs is introduced in a new city. So for example, in future, our city is planning to introduce an eHub as a mode of transportation in the city. You can just take the Amsterdam model and tweak the scale and then apply it. You will get the exact value of people who will be choosing those modes. So this is the utility of this exercise. It will save the time and resources in developing the new models. And finally, as I said, it was not just we transferred the model from Amsterdam, we also had estimated a separate model for Manchester data, and to find out whether where people are differing in their preferences. So what we found is like Manchester users, the respondents in Manchester are having more sensitivity towards the level of service of eHubs. So for example, they are very much conscious about the access time and distance for the eHubs, as well as the cost of the eHubs. So Amsterdam people might not get affected much as compared to, the Amsterdam people are not going to get much affected if the access distance is more. But if the same access distance is provided in Manchester, probably they won't choose that mode. So maybe this is because Amsterdam is already a cycle-oriented city, and Manchester is very, very car dominated, so they don't want to go and get a mode to go to their destinations. So if you want to attract the car users to eHubs, you need to make sure that the access distance is very less in Manchester. And also they are getting affected by the parking time, whereas the Amsterdam users are more sensitive towards the parking cost. So, and this red portion, the maximum differences that we found between Amsterdam and Manchester was in these three aspects. So Manchester people, as I already mentioned, they are very sensitive to the level of service of eHubs as compared to the Amsterdam people. Finally, the mode comparison. So as Fencha was mentioning that for different distances, we tried to measure, simulate the values and see what proportion of people are shifting. So for an average young person who is highly educated, for a distance of less than 2 kilometers, if you see both the cities, Manchester, they will still continue to use their car, around 70% of the people. And in Amsterdam, around 58% will still continue to use their cars. The blue one is car and the orange one is, by the way, public transport. When we move to 5 kilometer distance, it can be seen that the public transport user, it's interesting to see here, the people who will shift from public transport to the eHubs are roughly the same in both the cities. Around 60% of people will shift to eHubs. But in Amsterdam, they will choose, to a great extent, this shared electric vehicle. Somehow the presentation is, the last bit of this column is the shared electric bikes, and the middle one is shared electric vehicles. So in Amsterdam, people are shifting, the public transport users are shifting to shared electric bikes, whereas in Manchester, they are shifting to shared electric vehicles, which is a matter of concern, because if public transport users are shifting to the cars, then it is as it was talked in the morning session, it is sustained congestion. And as the distance increases, the good thing is that the public transport share is still retained, but the car share keeps on increasing as the distance is increasing. So this is the final comparison between Manchester and Amsterdam. And with this, I'd like to conclude. If you have any questions, please ask.
Thanks a lot, Van Gouw and Kuldeep, for your presentations. It's very interesting and necessary. Van Gouw, can you please join the stage again so we can start the Q&A? if somebody has a question, please raise your hand. I will walk around with this mic, and you can say if it's a question for Kuldeep or for Van Gouw and ask the question.
Good morning. I'm from the city of Leuven, so I know a little bit about the e-hubs, and I'm just wondering, how do you? The question was already raised this morning. How do you measure the sustainability of e-hubs? Because now we're talking about if you introduce e-hubs, what will be the effect? Who is going to use them? But is there a factor in it, like if you provide it on the long term, are more people going to use it? And what about the next generation that's not so car dependent as we are right now? Do you have findings on this in your research?
Yeah. I mean, the findings from our research is probably not very encouraging. As I explained, like public transport users are using e-hubs, which we don't want. We want people who are using cars to shift to e-hubs. But the important issue, again, it was raised in the morning session, that this cannot work unless you have some stick measure along with it. So in the last slides, I was mentioning that the respondents in Manchester are sensitive towards parking time. So unless you increase reduce the parking space in cities, it is difficult to shift people from cars. So although like e-hubs is a pull measure to attract people from other modes, but it's difficult to bring people out of the car, and there is no other way except using the sticks. So I just go back, like even in my PhD I had the similar thesis. So if you provide any measure standalone, like pull measure, be it e-hubs or say like you provide cycle lanes or anything, this won't work unless there is counter stick applied on it. So if Fencha want to add anything to this.
Probably two things, because you mentioned a long-term perspective, how the first thing is that on the long term, people can change. So the study we did here, obviously you can see it's a snapshot, so it did not consider how people can change. But you can already see that a thing we can probably do is that we can see how people's attitudes or their mentality can affect the choice, and then you probably only need to see how on the long term their attitude or mentality would change, and that would also in turn change their preference for shared mobility. And the second thing is, another thing you can consider is probably a diffusion study, because people will be affecting each other, and also the diffusion can also be affected by the supply of e-hubs, the level of service, and also some network effects. So that can also be an influence in the long term.
Okay. Any other questions?
I'm not sure if I said it right, but I heard 60% of the maybe users are coming from public transport. And what about the other 40%?
For 5 kilometer.
Sorry?
For 5 kilometer distance.
Okay.
So there were 3 distances, 2 kilometer, 5 kilometer, and 10 kilometer. So in the 5 kilometer range, if people are traveling for 5 kilometer, public transport users, so 60% of them are going to shift to e-hubs.
Maybe one thing to clarify, I think in Kuldeep's figures, he was saying that for public transport users, 60% of public transport users will stick to the current mode. It doesn't say that 60% of e-hubs users come from public transport.
And do you know something about that last question? Do you know when they use e-hubs, what did they use before?
You mean for current users?
Yeah.
For people who are already using it in actual...
No, if they want to use e-hubs, what did they use before? Did they go by bike or by car? Can we have?
We did the modeling for all types. So, for people who are using all types of modes, there are a part of them who wants to switch to e-hubs under different circumstances.
Hi, thanks for these nice presentations. So what I was not really clear for me. The first thing what you did was like more looking survey-wise, look at what people would do, right? In Amsterdam. And
Yeah.
then you apply that model. Did you like look at the predictiveness, or did you actually looked at what people were actually doing? So was it getting the data results from a year-long people seeing how they switch or not, or was it also still on the predictive level?
No, it was still in that level. So before implementation.
The data was collected at the same time in both cities.
Yeah.
Okay, cool. So I'm really curious, like, what the next steps would be. Like, if I can ask you, like, what would your next research will be? Because I have a feeling, like, asking people what they want to do or what will do is not so representative of actually what they will do.
Exactly.
I'm a designer, so I know this.
Well, in the project, there is, if you stay in the room for the next breakout session, there will already be studies conducted by Newcastle University. They collected data from people who have already used eHubs or other shared mobility, and their actual behavior change. There is a study on that.
And also, like, so the stated preference study that is normally done when a new thing is introduced. So it's not like it will go totally wrong, but there will be some sense, like with some degree of error, but it will still be correctly predicting. And most importantly, it will identify the variables that can cause the shift. So even if you're not predicting correctly, you know that, for example, young people are going to use it. This comes from the model. So this is the usefulness of those models. Yeah.
Okay, thanks a lot. Any other questions?
Do you, in your research, take into account that trips usually consist of different parts? So if we have commuters coming into cities, for example, they might use public transport to come to a certain station, and then from there, an eHub could assist them to go further. How do you, in your research, take into account the mode shift that happens then? Because if you ask somebody, would you normally walk? They would say yes, because there's nothing else. And then that's the data you get. Whereas maybe if they would not have that last mile option, they wouldn't even have come into that station in the first place, but they would have taken a car in total, if you understand what I mean. So for me, it's how do you make sure that you don't look too minimally at the one last trip that we're measuring, but that you look at the full travel pattern?
We did ask for people's full travel, but in this study, we only look at monomodal trips. So we did not cover when people who are currently already using intermodal trips.
Question for Kuldeep. You've done one transfer from Amsterdam to Manchester that worked reasonably well. And then you made a statement that because of that, it will work anywhere. Are there any factors that may change? Does it have to be the same male, gender, male, female, split, age, income, or are you confident that if I'm from London, Rome, Paris, Madrid, it will work?
Yeah. So in my second slide, I showed that Amsterdam and Manchester are very different when it comes to their current travel behavior. So if two very different cities, we are applying models, and if it's working, probably if, say, the Manchester model, if we are applying to a city which is the Amsterdam model, we are applying to a city where, which is the cycle-oriented, bike-oriented, probably it should work more. And secondly, the models that are performing nice are mixed logic models, which are very flexible in a way that they account the individual preferences as well. So as I showed, like the constant values in the model, they become individual specific when you have a mixed logic model. So because it's a flexible model, probably should work for the other cities. And most importantly, I know it's not like proven, but if it is getting implemented in a very different city to a 70% extent, it should work for the other cities. But yeah, this is like not a sweeping statement I would make so far. Like we should test it, but yeah.
Any other questions? Something you want to say? Was not a question. Okay, I think we might finish then. So thanks a lot for this presentation, for this session, Van Gouwen and Kuldeep.